All right, let's talk about chemical formulas. A chemical formula of a substance, what it does is it shows the chemical composition of the substance. It shows us the ratio of the elements present in the molecule or compound. That is, if there's more than one element present of that type, there will be a subscript on the lower right, which tells us how many. They can come in a couple of different ways. You can have monoatomic or single atom elements like iron or potassium or zinc. You can get diatomic elements like oxygen, nitrogen, fluorine, chlorine, bromine, iodine, hydrogen. They're all two elements, and you need to remember those as we go forward. I put a little chart down here. If you notice, they form a little number 7 there on the periodic chart, plus hydrogen all the way to the far left. Those are all diatomic, and particularly some of the more commonly encountered ones like hydrogen or nitrogen or oxygen. Maybe not as much astatine you might not encounter as often, but the other ones you'll see a fair amount in some reactions, and you need to remember that once we start writing reactions, it'll be important that you remember to do that. And so when somebody says oxygen gas, they mean O2, not just O, and N2, not just N, for example. But if we have some more complex elements like O3, which is ozone, phosphorus is P4, sulfur S8, we can get more complex compounds like H2O, and glucose or blood sugar is C6H12O6. Now, elements can come as allotropes. That is, they're the same element, but there's more than one form. For example, oxygen, O2, is oxygen gas, but O3 is ozone. You breathe one and it helps you live. The other one can be fairly toxic, and it's sometimes a summertime pollutant, and people with respiratory conditions have problems if too much forms in the atmosphere. But there are several, for example, oxygen and ozone, carbon, diamond and graphite are the two most common, but you can get soot, as you can see from the picture down there, from a fire, fullerene, which is a rather complex cage, almost soccer ball shape. And there are quite a few allotropes of carbon that aren't here. Phosphorus comes in white and red. Red, for example, is on your match head. White ignites on air and was used a lot during the Vietnam era in mortar rounds, and has since been banned by the Geneva Convention. Now, if we look at atoms and compounds, remember we said that subscript told us how many of each type. And so H2O means there's 2 hydrogen atoms and 1 oxygen atom. NH3 means there's 1 nitrogen atom and 3 hydrogen atoms. CO2 means there's 1 carbon atom and 2 oxygen atoms. C4H10 means there's 4 carbon atoms and 10 hydrogen atoms. Next lesson we'll pick up with ionic compounds.